Good morning, everyone. We are the Group 5 and we're about to discuss the MongoDB indexing and sharding. So, indexing in MongoDB. Indexing, it is where we, instead of scanning all the documents in your collection, indexing is a data structure that stores a small portion of dataset in a format that allows for quick searching and retrieval. So, ayun nga, indexing, um, um, knowing na may large dataset ka na hawak, um, instead of i-scan yun, kunwari may hahanapin kang isang document. So, instead of i-scan niya yun ng isa-isa na do sa large dataset mo, um, indexing, mas mapapadali niya yung paghahanap dun sa hinahanap mong document na yun. Kasi nga, naka-store na siya into small portions. So, dun na lang siya magfo-focus na maghahanap dun sa specific na document na hinahanap mo. So, no need na i-scan niya isa-isa yung document na nasa collection mo. So, importance of the indexing in MongoDB. Without an index, MongoDB must scan the entire collection to find matching documents, which can be slow, especially with large dataset. So, yun nga, yung sinabi ko kanina. If wala kang index, i-scan niya isa-isa yung mga document na nasa collection mo. But then, with index, ayun nga, mas mapapadali niya mahanap yung documents na need or hinahanap mo nga dun sa large dataset na meron ka. And indexes reduce the number of documents that need to be scanned, thereby lowering CPU and memory usage. Yun nga, 'di ba? May large dataset ka. If hindi ka nag-index or walang indexing na ginawa, i-scan niya yung isa-isa, then dun pala sa pag-scan niya na isa-isa sa large dataset mo, is kukunin niya na lahat, is marami na siyang kukunin na memory usage sa'yo. So, in a long run, isa yon sa magiging problem mo. So, indexes can improve the performance of sorting and range queries. So, sa sorting, for example, sa phone book mo, 'di ba sa phone book mo meron kang list of names doon sa mga numbers niya. Nandun yung contact numbers nila. Then kunwari walang sorting na nangyayari. Kung hindi yan mga nakasort, if for example hahanapin mo yung Gemilins na pangalan, yung Gemilin na yon, iisa-isahin mo pang hahanapin sa may phone book mo. Kasi nga, hindi siya mga nakasort. But then, if nakasort yung mga yan, hahanapin mo na lang yung yung Gemilin sa may J na sa may mga J na pangalan. So, doon sa list na yon, mas madali mo na lang siyang mahahanap. So, in MongoDB, in connection with MongoDB, it's like, kunwari, may mga document siya. Naka-index yan by alphabet. Kunwari, ito yung document ng letter A, na mga letter A yung first name, B, C, and D. So, if J yung and so on, if J yung hahanapin mo, magfo-focus yung pag-scan ng MongoDB sa may index or sa may mga document mo na letter J lang yung mga nasa first name. And these are the types of indexing. We have the single field index. Single field index is an index created on single field of a document as is. So this is the sample code that we have. For the DB, that's students. These students here is our collection name that we created sa natin sa may MongoDB natin. Then, yung create index, ayun nga, yun yung pag-create natin ng index, which is dito sa example natin or sa sample code natin is yung gagawan natin ng index is yung name na naka-sort into ascending order. And then the compound index, it is an index that includes multiple fields within a document. So ayun nga, another, yung sa natin, sa sample code natin, nandun yung collection natin, then yung pag-create natin ng index. But then, dito, sa may GPA, ay sa may natin, gagawan naman natin ng ng index yung GPA and enrolled courses natin na both naka-assigned into naka-assigned into ascending order.
Next, the multi-key index, an index used for fields that contains arrays allowing each element in array to be indexed. So, the code is dv.students create index, which is the tags in ascending order. A multi-key index is an index type in MongoDB especially designed for fields that contain arrays, indexing each element within the array. This is particularly effective for queries on array data, like when looking up students enrolled in specific courses. If the courses field is an array, by indexing each array element, MongoDB can retrieve records faster based on array contents. For example, in enroll courses, there are 4 arrays in enroll, and you index them. And then when you search the GPA, which is the greater 3.0 in specific enrolled courses, for example, the C001, the result will be given by the MongoDB. Papakita namin yun mamaya sa example codes. Next is the text index, an index designed for text searching on string fields. The code is dv.students create index description text. A text index is created for full text search capabilities on string fields. It enables efficient searching for specific keywords across documents, such as finding all students who mention, for example, math in their descriptions or notes. This type of index is optimized for text search, allowing quick and relevant results in fields with unstructured text.
Next is compound index. A compound index is an index on multiple fields. It is designed to optimize queries that involve multiple conditions. For example, searching for students based on both GPA and enrolled courses. How to optimize? Compound index work by optimizing queries where the fields in the query match the order of the fields in the index. Just like Gemboy said, MongoDB uses the compound index to retrieve documents efficiently without performing a full collection scan.
Indexing strategies. Where to use indexes. Use indexes on fields that are frequently queried, filtered, sorted, or joined. When you have fields in your documents that are commonly used in queries, adding an index to these fields can significantly speed up the data retrieval. Compound indexes are useful when queries often involve multiple fields. If you queries typically filter based on more than one field, a compound index can index a multiple field. Can it can improve the performance. Text indexes are best for search queries on string fields. When you need to perform full text searches on string data, using a text indexes is the best approach. Text indexes enable efficient searching for keyword or phrases, making it easier to retrieve documents that match match search fi- that match search criteria. Um, Trades off. Gogi, may daga. Ulit.
Yun, pinonsin pa mo.
Bakit?
Next mo. Eh, balik ka mo. Tapos stay and go.
Trade-offs. While indexes improve read performance, they come with a trade-off: wide performance. Um, Although indexes enhance the speed of read operations, queries, they can negatively impact write operation like inserts, update, and delete. Every time you modify a document, kailangan updated din yung MongoDB mo. Additional overhead can slow down write operation, especially if there are many index to update.
Indexes consume storage space. Each index requires additional disk space to store the indexed data. The more index you create, the more storage space your database will use. This can lead you increase costs, especially if you're working with large datasets or limited storage capacity.
Today, I'll be walking you through a Python script that interacts with MongoDB to manage student records. First, we have to create a database name, which is the stud underscore record, and the collection name is the student, and create database. And after we create a database name, let's proceed to, we started by importing essential libraries. First, we import Mongo client from Mongo, which allow us to connect to our Mongo database, MongoDB database. Then we also import JSON, random, and Faker. Using a Faker is really handy. It helps us generate fake fake data, making our testing more realistic without having to manually create it. And next, start it. And next, we create an instance of Mongo client to connect to Mongo running on our real machine. We then access or create a database name to record and the collection name student. This is a great feature of MongoDB. If the database or collection doesn't exist, it gets created automatically when we try to access it. And we know to prepare to generate data. We create a list of course code and initialize initialize an empty list to store student records. Generating course codes pragmatically like is make it easy to scale. Imagine having hundreds of courses. This approach save us a lot of time. This code generate a list of course codes in the format C001, C002, and so on. And this then code initialize an empty list to store student records. Here's where the magic happens. We look 10,000 times to create student records with a random attribute such as student ID, name, age, enrolled courses, major, GPA, and enrolled year. Notice how we use random sample to select a few courses from our list. This simulates a real-world scenario where students enroll in multiple courses. And this code formats student ID as 5-digit string 0001 and so on. And this code generate a random name. And this code generate a random age between 18 and 27. This code randomly select a gender, which is the male and female. This code randomly select 2 to 4 courses codes, which is the course code. And major, random that choice. Randomly select a major between mathematics, physics, biology, and chemistry. And the GPA code randomly that uniform. Generate a random GPA between 2 and 4 rounded to 2 decimal places. This code randomly that choice randomly select an enrollment year between 2018 to 2024. This code add the student record to the student list. After creating the student records, we insert them all in the student collection using insert many. This bulk of insertion is efficient. Rather than inserting each document one by one, we save time and resources by doing it in one go. And we have to insert and wait for it. Now, as you can see, the insert mini result is now already happened. And let's check in the MongoDB and student. And now the data value is now in the MongoDB and 10,000 documents. After that, next, we create indexes to improve query performance. First, we create a single index on the name field in ascending order. Indexes are crucial in database. Allow us to speed up searches. Significantly, imagine searching for a student in a list of thousands without an index. It would be a nightmare. And then we in this code print the result of the index creation, which is typically the index name. And this code we retrieve and display all the indexes on the collection to see what we've created. This helps in managing and optimizing our database effectively. And now let's run it. And the single index on name is now happened. And let us check it. And refresh. Now the index that we create is now happen in MongoDB. And now we proceed to create a multi-index on enrollment courses filled in ascending order. One indicates ascending. Here we created a multi-key index on enrolled courses. This is especially useful when our field contains an array like the courses that a student is enrolled in. Multi-key indexes help MongoDB handle queries on array fields efficiently, which is great for retrieving records where students are enrolled in specific courses. This code print create a multi-key index on the enrolled courses field in ascending order. And this code print the result of the index creation, the name of the index, and this code retrieve a list of all indexes of the collection, and this loop through the list of index and print each index. And now let's run it. And now as you can see, makikita natin yung mga ginawa nating index. This is the single index and now this is the multi-key index. Let's check it in MongoDB. Now the enroll courses is now created. Next, we create a compound index on both GPA and enrolled courses. This is useful for queries that involves both fields like finding student with a specific enrollment enrolled courses and a certain GPA range. A compound index is optimized multi-field queries which can save a lot of time when searching through a large data. And this code create a compound index on GPA field ascending and in ascending order and enrolled courses field in descending order. And now this code print the result of the index creation, typically the index of the name of the index. And we retrieve the list of all indexes on a collection and the for loop through the list of indexes and print each one and run. Now the index is created. Enrollment courses -1 and name GPA 1 enrolled courses -1. Now and the index we created is now in the MongoDB and as you can see the properties of the compound is now compound. And now we also perform queries to find specific documents. For instance, we create find all documents. This will do it. We also perform queries to find specific documents. For instance, we can find all documents with the name Ryan Black, and this loop through the cursor of found documents and print each document. And now let's run it. And now we find the one record, which is the by Ryan Black. And we also create queries to find a specific GPA greater than 3. This code find all documents in the collection where the GPA field is greater than 3 using the $GT operator. And we use the for loop through the cursor of found documents and print each document. And now let's run it. And we can see the result. It's so madami. And this is how the indexing works.
So let's proceed in sharding. So sharding, this allows MongoDB to scale horizontally, meaning you can handle a group of, a growing amount of data by adding more servers rather than upgrading a single server or vertically scaling it. Then sharding is especially useful when a single machine can no longer handle the read and write, or the dataset becomes too large to fit in one machine. And sharding key, it is a um, ch- I mean, choosing an important sharding key is crucial for avoiding performance issues. A poorly chosen key could result in uneven data distribution, leading to hotspots, and where one shard handles a disproportionate amount of traffic while others remain underused. Then, for example, if you are sharding a student database, a common sharding key could be di ba, student ID. MongoDB will use this field to determine where each student records is stored, ensuring that records are spread evenly across shards.
MongoDB support different strategies for how data is distributed across shards, depending on how the sharding key is processed. Range-based sharding. Documents are distributed based on a continuous range of the sharding key values. Each shard holds a specific range of key values. However, if the data is not uniformly distributed, for example, new records all have a high values, it can cause some shard to become hotspot, leading to uneven data distribution and perform issue. Um, when to use when to use range-based sharding is useful for fields that are naturally increased or decreased, such as dates or sequential numbers. However, it can lead to imbalance if certain range are accessed or written to more frequently than others.
Next one is hash-based sharding. Instead of using ranges, MongoDB hash the value of the sharding key and distributes documents based on the hash value. This creates a random and even distribution of data across all shards. When to use? Hash-based sharding is effective when you want to ensure an even distribution of data and avoid hotspot. It's useful when your dataset does not have a natural ordering.
Sharding strategies. Optimal sharding. Selecting the right sharding key is crucial for achieving good performance and scalability. When deciding on a sharding key, you should consider the following. First, the high cardinality. Use keys with unique values for even data spread. Example given is student ID over gender, which is unique for student ID, which is unique for each student has high cardinality, whereas gender has low cardinality since there are only few possible values like male and female. Next, access patterns. Pick keys frequently used in queries to minimize cross shard operations. For example, if most of your queries filter records by student ID, it makes sense to use student ID as a sharding key. So MongoDB can quickly route queries to the correct shard. Avoid hotspots. Ensure the key distributes read and write traffic evenly across shards. For example, if you shard by a sequential value like a time stub, you risk creating a hotspot where all new writes go to the most recent shard, causing it to become overloaded. High base What I mean is hash-based sharding might be a better option to distribute the load evenly across all shards. Now let's proceed to the coding part. This time I will walk you through setting up a MongoDB sharded cluster with replica sets. This setup is essential for scaling large data by distributing them across multiple servers, which improves performance and reliability. To start, we create directories to store data for our config and shared server. These structures helps organize files to each component of cluster. Now the directories is now created. Let's see if they created. And here, after we create, let's start config servers. Now, config servers hold metadata about the cluster, such as which shard stores specific data. We need a plus 2 for redundancy. Here we were here we are starting to config servers on ports 27018 and 27019, both part of the RS1 replica set. And let's start the two config. And the first config is now start running, and the second also running. And then we create an add command, and we initiate the replica set RS1 to ensure high availability of the config servers to run the Mongo's port. And now let's start the Mongo's port. And now the RS initiate, and And now the RS is now okay. And let's check RS that status. And now the RS is now officially primary, which is the first config, and secondary, and minimize. And let's start. Next, we start the first shard. Let's create another command, right? Command. Then, next, we start first shard server on port 22702, making it part of a new replica set, which is the RS2. Shard servers hold the data, and each replica set provides fault tolerance. And now start. And now the first shard server is now running. And now let's start the second shard server in the same right command prompt, but we can add it. And we start second shard server also in RS2, but this time on port 27021. And which provides redundancy for the first shard by replicating its data. And now let's start. And now the second is already run. And we have to initiate the shard replica set port, create another command, and Mongo's port 2702, which is the first shard. This port is connected to the first shard server 1. And now let's run and test and initiate the replica set, which is the RS initiate, and paste and enter. And now we have to check. I forget the RS initiate, which is the ID. This time is RS2. While ago is the ID is RS1, which is the config server, and now this time RS2 is the shard server. And let's check the status of the shard server. Now there are two, which is the primary and secondary. After that, repeat for the third shard, which is the replica set. And now we set up third shard server on port 327022 as port of another replica set, the RS3. This shard will store additional data, allowing our cluster to handle even more data value. Next, let's start the fourth shard server. We start the fourth shard server on port 27023, which port of RS3. And let's start. After running all the server, let's connect and initiate the port, which is the initiate the second replica set. Finally, we initiate the RS3 replica set to replicate data between the third and fourth shard servers. Then now Now let's check it. RS dot status. Always check the shard status to see if and this the state status are primary and secondary. And now create another command, minimize it, and start Mongo's router. The Mongo's router acts as an interface between application and the sharded cluster, allowing data to be distributed across shards. We start it with the reference to the config server for coordination, which is the Mongo's config db rs1 localhost 27018 and localhost 2719 in port 200 27050, which is this is the unique that we create for this connection string. And now run. And if the port 2705 is running, you have to minimize and connect to the router, which is the Mongo's port 2705. We connect to the Mongo's router and run, and now you can see the direct Mongos test, which is nasa loob ka na ng Mongo shell. After that, create a shard and our we connect to the router and add our shard replica set, which is the RS RS2 RS2 and RS3. The add command allows us to specify the replica set name and its member servers, which is the RS3. And shard added, it means the shard is added, which is the RS2 and RS3. Now, let's check the let's check the status. As you can see, sharding version, and we have two shards, which is the RS1, RS2, RS2 and RS3. And our Epic Mongo version is 7.02, 7.0.14, and auto split, yes, currently enabled. And balancer, it's currently enabled, yes, but currently running no. And this is the database. And config for partition true and collections. There is one collection with the config.system session, which is automatically. And now, after that, we have to use demo and yes, switch to DB demo. And now, show DBs if there's its database. And now there is two admin and config. And now let's go to MongoDB and add new collection. And this time, let's create a connection which is the 5027050 and rename it new connection. And save. And now connected to new connection. And now let's create another, which is the demo, and the collection name, which is the patient. I mean student. And create database. And now let's go back to the command prompt and show collection to show if there is exist collection. And now there's one, which is the student. And now let's go back to MongoDB and import data and import. Now we have 1,000 documents imported in student. After that, and now as we enable sharding for our specific database. This tells MongoDB that we want the database to be sharded across our configure shard, which is sh that enable sharding and close open parentheses and quotation and your database, which is the demo. And after that, run. And now, okay, class end is check at sh dot status. And now we have database, which is the demo, but there is no collection already. And after that, after enabling, we have to shard the and now first of all we have to create an index. Dv dot, which is the student dot create index, create index and close open parentheses and curly bracket, and which is the student id. Now wait a minute, and yes, tama is student id, student underscore id, and and we're going to hash hash range base first. And now let's run. Now the student ID hashed is now created. Let's go back to MongoDB to check if the index create index is exists in MongoDB and refresh it. Now student ID is now hashed. Now we will go back to the command prompt and let's try the collection. Finally, we choose collection database, which the database name, which is the demo. and the collection name, which is the student, and the field name, replace it into the student ID, and now within the database, we choose a collection within the database to shard and select a field to use as the shard key. In this example, we were sharding by hash value for even the data distribution. And now let's run. And now collection sharded demo.student. We database number of chunks, which is one, and database, which is demo. And now collection is now the collection sharded is now officially collection is now sharded. Demo that student. Now let's check the status. It says this status. There are two shards within the RS2, RS3. And now the databases, which is the databases collection, is now database demo and collect. We have the collection. While ago, the database demo is no collections, but this time the database demo is has a collection, which is the demo that student. Chart key student is now hashed, and now the chunk is one. And now let's get the sh that get sharded data distribution. And now let's run. Now the now as you can see the distribution, the IS shards, the shard name RS2 is now own documents 22. And in the demo that student shards is RS3. Shard name RS3 now on documents 1 and own size bytes is 124,000. Now let's create um another let's go back to Mogo, another example which and add, which is the university. This time the document is more. And now let's import university DB. And now the 100,000 documents is now officially imported. And let's go back to the command prompt. Now, similarly, we share the university collection. We have to create a new index, which is the dv dot university. This time, we're going to use another collection, which is the university, and create index. And we're going to use student ID But this time we're going to use one which is the range based. And now let's run. And now student ID is now created. Let's go back to MongoDB and let's check the refresh. And student ID is now created. Student ID index is now created. Now let's go back to command prompt. And we have to shard. We have to copy the exist data and yes. And same process. Demo the database name and the collection name, which is the university, and the field name is the student ID, and and one. And now let's run. Now collection sharded demo.university. Okay. And cluster. And now let's check the status. Now there are two collections, which is the demo.student and demo.university. Let's check the dv.university dot get shard distribution. Now in shard RSD and RSD, the totals is 100,000, and this is the this is the sharding works. And this connection we will not close it because we're going to use the connection later. Now, after the first part of our report, now we will proceed to the second part of our report, which is the code demonstration, implementing indexing and sharding. This time, we will go to step by step walkthrough and in advanced indexing, and we will use to explain how the indexing works and how the before and after indexing. First, we go to the Jupyter notebook and now let's wait. Mm, first, first, the first line imports the first line imports the Mongo client class, which is essential for connecting to MongoDB database. And the second line, the Mongo client object is created with the connection string pointing to the localhost port 27017, where MongoDB is typically hosted. And the third line is the university database is selected. If it doesn't exist, MongoDB will create it when the first written. And the fourth and the last line, the student collection is selected. Collection in MongoDB are analogs to tables and relational database. Now let's run and let's check the MongoDB. Mm. Refresh. And now let's create a database, which is the university DV, and the collection is student. And create database. And now, after that, and now let's import data, which is the university DV, and import. And let's wait for the importing. Hintayin lang natin saglit na matapos yung pag-import niya. And now the documents 10,000, I mean 100,000 documents is now officially imported. And next, let's go back to the Jupyter notebook. And now, nag-video ako. And now, dun ka na sa end mo. And now, a query is constructed to filter students who have a GPA greater than 3 and are enrolled in a specific course, which is the course 3001. This query will later be optimized with indexing. And let's run and another. And this line of code, the explaining the query execution plan before indexing. So the explain close-up inferences method is called on the query to analyze how MongoDB would execute it without indexing. This provides valuable insight into performance issues, insights into which such as whether a collection scan will occur. Now let's run. And now, and now, this code will show the execution plan before creating the index. Let's see the result. And this is the result. Version 1, which is the filter, and the winning plan stage is called scan, which is the collection. All the collection is scanned. All the documents is fully scanned. And now, let's proceed to the, and now we will create an index in create a compound index on GPA and enrolled courses fields in the student collection. This index will optimize queries that filter on both fields, improving performance. A compound index on GPA and enrolled courses is created. This step is crucial as it enhances the efficiency of queries filtering on these two fields. Now we will run it. Now the compound index is now created. Let's check to the in MongoDB indexes and refresh. And now GPA enrolled courses is now created. Now and the properties is now compound, which is it's already compound. Now let's create another code, which is the after index explain collection find query explain. This same query is executed and explain is used to see how the extension plan has changed after the creating the index. This allows for direct comparison with the previous plan. And now let's run and then let's print the result. And before index, the winning plan with the winning plan stage is called scan, which is collection scan. The filter is utilize a filter that check for enrollment courses equal to C001 and the GPA is greater than 3. And the total docs examine, which is the document total docs examine is 100,000. Documents were scanned to find the results. Lahat ng documents, it means lahat ng documents, dinaanan niya para ma-scan, para mahanap niya yung hinahanap natin sa query. Next, documents return. Saan ito? Documents return. And documents return. And the documents return is 337,190, which is the execution time is 673 milliseconds. And the total key index examined is 0, which is no index was used. And now let's compare to the after indexing. The winning plan is stage which which within an scan X scan, which is the index scan. The index and the index used is GPA enrolled courses 1. And the total key index examined is 37,190, indicating the number of entries in the index were examined. The total docs examined is 37,190. The documents returned versus dun sa after dun sa before indexing, the total document examined is 10,000. Oh, I mean 100,000. But after indexing, the total docs examined return is 37,190. And the total key and the case examined is 37,290, indicating the number of entries in the index that were examined. And for the execution time, there are 537 milliseconds. The efficiency, the query is still returning the same number of the documents. It's 37,190, but use an index to do so. For the performance, the execution time in after scenario 537 millisecond is slightly smaller than in the before scenario 673 milliseconds. This can be attributed to the overhead of using in the index, which is often a trade-off for faster query performance in long-term efficiency. The total number of documents examined dropped significantly from 100,000 to 37,190 in the after case, demonstrating that the index significantly improved query efficiency. For the implication, use index, the transition from a collection scan to an index scan is crucial for performance improvement, especially as the data grows. The index allows MongoDB to quickly narrow down candidates that meet the criteria rather than examining every document. So that's for the indexing. A while ago, we opened the port, which is the 2705. Now, we will go to the MongoDB shell, which is the new connection, and go to open Mongo shell. And now we going to enable, and next, we will start by connecting to our MongoDB instance, which is the 27050. Next, we enable sharding for our database, which is the University DB, which allow us to scale our data across multiple servers. After that, we then create a collection name, students. First, use University, University DB, and run, and then and then we and DB collection. We create DB collection, which is okay. After that, here we share the students collection by student ID. This distributes our documents across different shard based on the student ID value, improving ac- ac- access speed. Okay, now is collection sharded. After that, we import data. Okay, now we run and now we run a query to find student with a GPA greater than 3 and measure how long it takes. We note the number of documents returned at the execution time. This query before sharding. And now 26173 milliseconds. Now, we have to create an index. And next, we to optimize the firmware, create an index on the GPA field. This allows MongoDB to quickly locate documents based on the GPA values. Next, we run another code. Finally, we run the same query again while we expect similar results since sharding was applied. This is how sharding can benefit performance in larger data. This is after this query after indexing and sharding. And none? Yeah. As you can see, the documents returned before sharding is 261. Documents returned after sharding 261. The same documents returned. But the execution time before sharding is 73 milliseconds. In execution time after sharding is 57 milliseconds. That's how the sharding is really important and indexing in large database. And that's all. Thank you. Bye.